Hello students, our topic today is about normalization. Let's take a look on this table. So we have here information about the lecturer having lecturer ID, lecturer name, and salary. So you can see here we have teacher Shaima, Fatima, and Said. Then we also have information about the department. We have department ID and department name. Then we have also course code, course name, and the passing grade for the course. Aside from that, we also have here the teaching experience. So if you will study the table, this shows information about the lecturers, the departments, the courses, and also the teaching experience of the teacher teaching this course. So if you will check this one, so we have the lecturer ID and the course code. So with the lecturer ID and the course code, we can determine the teaching experience of the teacher. So what we have here are the keys, lecturer ID, and the course code. But we have problems here in our table. So we have three problems, which is the insert anomaly, delete anomaly, and update anomaly, or simply insert, update, and delete anomalies. So anomalies are problems. So for example, we have a new teacher. Let's have an ID of L4, and then the name of the teacher is Ahmed, and his salary is also 600. So when inserting a record, we can insert information about the lecturer, but the problem is if there's no assigned department for that teacher yet, and also there's no course information, so this will be left blank. So this is what we call the insert anomaly. So if we try to insert information of the lecturer, we also need information or details of the department, the courses, and the teaching experience. But what if there's no available information yet for these columns? So this will be a problem in the table. Another kind of problem is what we call the delete anomaly. So for example, I will try to delete one record which is for Dr. Fatima or for Fatima teacher. The problem is when we delete the lecturer, also the information about the department will be deleted, and also the course information and the teaching experience. So the entire row will be deleted. But what we intend is only to delete the teacher. So this is a problem of delete anomaly. The next problem is what we call the update anomaly. So for example, for the passing grade of the course networking, we want to change it to C only. But the problem is you have to update all relevant rows. So we have here 3 networking courses and passing grades. So we have to update the 3 relevant rows to only C. So what if you have 1,000 records? So it will take time for you to update all these records. So that is the problem of the update anomaly. So now let's put the table on its original state. Okay, so we have our basic table. So in this example, we have teacher Shaima teaching 2 courses, and also teacher Fatima teaching 2 courses, and for Mr. Said, we have 1 course. Okay, as you can see, this row represents also the data from the first row. So it means that Shaima is also teaching in this course. So we don't have the we have here null values for the second row, but it means that this row is also for teacher Shaima. Okay, so but for the problems that we have for single table in our database, so it will have again the anomaly. So what we do the process of normalization. So what is this normalization? Normalization means it is the process to reduce the data redundancies and anomalies in our table. It has the 3 steps or normal forms that we have to follow. So in the first normal form, we have to remove the repeating group, identify the primary key or foreign key, and also add a name for our tables. So that will be our first step. And then second step is to make sure that it is following the rule in 1 and F, so meaning no repeating group. Then we have to separate the partial dependency in our table. So in our case, we can separate the partial dependency, but my technique is also um, separating the full dependency. Okay, full dependency in our table, or we call it the FD. And you have to identify the primary key, foreign key, and add names for our tables in the 2NF. Now, after removing the partial dependency and also the repeating group, we can now move to 3NF. So in 3NF, the table must be in 2NF, meaning there's no repeating group and no full dependency or partial dependency. So all attributes should be dependent in one key attribute only. In 3NF, we have to remove the transitive dependency or dependency on the non-key attribute. We have to identify also the primary key and foreign key. And lastly, we should add names for our tables. So this is the process that we have to go through to normalize our table. We want to reduce the data redundancies and anomalies in our table. As we can see here in our table, we have what we call the data redundancy. So where is the data redundancy? So this is our example here. So teacher Shaima will be having 2 rows since she is teaching 2 courses, and we have teacher Fatima also teaching courses. Okay, so in finding the repeating group, we can check the double value or the duplicate value for our rows. So we have here L1, L1, Shaima, Shaima, and then IT, ID. So meaning, from here, lecturer ID to department name, so this will be our repeating group. So remember, in 1NF, we have to separate the repeating group to a new table. So remember, it's like having a dividing line when you split your table or separate your tables. So what will happen is that it's like having a dividing line in the middle. So here, from the repeating group. Okay, so now what we need to do in 1NF, so we have to write here 1NF. Okay, then we have to remove or copy the repeating group to a new table. So I'll just use copy and then paste. So now we have the first half of the table which contains the repeating group. Okay, so in this case, we want to have the lecturer ID, which determines the lecturer name, the salary, department ID, and department name. So if you will look at this, if we will make the lecturer ID as the primary key, then we have here some violations in the primary key. We have duplicate values for L1 and L2. So what we have to do, since it's the lecturer ID is the primary key, we just have to remove the duplicate value L1 and also duplicate value for L2. So now we are only having L1 for teacher Shaima, L2 for teacher Fatima, and L3 for teacher Said. Okay, so do not remove this yet. So we will remove that in the later phases or stages in the normal form. So now we have removed the repeating group from this table. So what will happen to the other half? So we can copy the other half as a new table also. So we can copy and move it a little here. Okay, but take note, once we copy the other half of the table, we have to also copy the lecturer ID as part of this second table. Why? Because remember, we need the lecturer ID and the lecturer ID here to connect our tables. And aside from that, we have what we call the composite primary key. Okay, so in this table, it shows the lecturer ID, the course code, which actually determines the teaching experience of the teacher. So meaning we have to know we can determine the teaching experience based on the lecturer ID and the course code. So this means that our composite primary key are the lecturer ID and the course code. So we can put underline to that. Okay, so these are the dependencies. Okay, we call it the full dependency. So also here we have to put underline for our composite primary key. So we can have we can check here that if we only have one primary key on the table, it will be a problem for the lecturer ID because we have duplicate values. Now, to remove the duplicate values, we will not delete it in this case. Why? We have here another key value, which is the course code. So, if you combine the lecturer ID and course code as the composite primary key, then there will be no duplicate. So, this is called the composite primary key. Okay, so again, when you split the two tables, you copy the repeating group and put it on a new table, and then the other half you put it on a separate table also, and connect the lecture ID to these courses. Okay, again, in 1 and F we have to separate the repeating group, then identify the primary key and add names to our table. So in this case, in the 1 and F, we have the lecturer ID as the primary key for this table. So we can name it as lecturers. So this table contains the information about the lecturer. So just remove the ID and then that will be your table name. We can add lecturers with S or without S if you want. Then the next table actually contains information about the lecturer and the course. So what we write, so based on the primary key, we have lecturer underscore course. So the code there is course. Okay, so let's just make it this big. Copy this one and here. Okay, so you just have to expand our column. Okay, so I merge it. So this is the 1 and F. Okay, so when we split the table, we can identify the repeating group, put it here, and the courses on the other side. Copy the lecturer code or lecturer ID here. So do not delete anything. Only here, since we only have the primary key as the lecturer ID. So no repeating values for the lecturer. So the next step is the 2 and F. So in the 2 and F, it must follow the rule in 1 and F. Second, we should separate the partial dependency, which is the dependency on part of the composite key. Okay, in my case, I also start with the full dependency. We remove the full dependency in a separate table and partial dependency on a separate table. So let's go back to our example. Let's find the full dependency in the table. So here, we don't have here the composite key. Okay, so this column or the lecturer ID determines the lecturer name, salary, department ID, and department name. In this table, we have the lecturer ID and course code that determines the teaching experience. So this is what we call our full dependency. So we have the composite primary key, okay, that identifies our lecturer, the teaching experience of the lecturer. So this is what we call the full dependency. Then another dependency that we can check on this table is we have the partial dependency. The course code determines the course name and also determines the co-passing grade. So this is what we call the partial dependency. So now it's up to you when which one you will remove first. So in my case, I remove the full dependency on a new table and the partial dependency in another table. Okay, so let's do now the 2 and F. Okay, so we have the lecturer code, course code, and teaching experience. We can put it in another table. So I'll just copy and paste. So we have the 3 columns. Now, how about the remaining? So for this, we get the partial dependency, copy, and then put it in another table. So we have to paste. So this time, I have to adjust the size of my column. Okay. Okay, so now we have the lecturer code, course code, and teaching experience together, and then we have here for the courses. Okay, so in this course table, the primary key is the course code. So remember, in our in our primary key, there should be no duplicate. So, as you can see, C1, C2, and then C3, and then C2. So, we have duplicate value for the networking. So, what we have to do, we can delete this, okay? And then delete also the networking down here. So, we must have only C1, C2, C3 in the courses. So, highlight, okay? And then this one, we can remove by removing the border. So, this is now our table for courses. Okay, so we can name the table as, again, so we have the lecturer course, because we have here the two, lecturer underscore course, and then, okay, merge. Then this is about courses, so we can tell that this is about course. So this will be our name for our table. So now, what about the lecturer? So since this is normalized already, and there's not really normalized, but there's no partial dependency in it. So in 2NF, we remove only the partial dependency. So what we need to do, we just have to copy the first table in the 2NF. Take note that probably our transitive dependency will go on the other side of the table. Okay, so it could be on this side or on this side. So, but remember, first we have to remove the repeating group. Okay, then in 2NF, we have to remove the full dependency or the partial dependency. And then just copy the table that is having no partial dependency or full dependency. Next will be the 3NF. So in the 3NF, it must be in 2NF, no repeating group, no partial or full dependency. No, what we do is, in 3NF, we have to separate the transitive dependency. So meaning, the dependency based on the non-key attribute. So remember, in our table, we have the composite primary keys lecturer code, lecturer ID, and course code. Okay? Partial dependency, which is, since course code is part of the composite primary key, so we separate it here. So these two tables are already normalized because the dependency in the table, in the course, depends on the course code. So the course code determines the course name and the co-passing grade. There's no partial dependency because we have the primary key already, and there's no transitive dependency. Though this is already normalized. As well as the lecturer course, this is already normalized. So there's full dependency on lecturer ID and course code determining the teaching experience. Now, when you look at this table, lecturer, we have what we call the transitive dependency. If you look at D1, so if you know if the department ID is D1, it can determine the department name, which is IT. If it's D2, then it's business, D2, and then it's business. So we have what we call the transitive dependency. There is dependency on the non-key. Department ID is not a primary key. So there's dependency on it, so we call it the transitive dependency. So department ID determines the department name. So this is what we call the transitive dependency. So what we do in 3NF, we have to remove the transitive dependency. So I have to write here 3NF. Okay, so let's just make it bigger. And of course, we have to add a color for that. Okay, so now what do? So we remove or separate the transitive dependency on a new table. So probably I'll add it here. Okay, then what about the remaining table? So if you split here, okay, you have to copy up to the department ID, okay, and paste here. Okay, so we split the table. Again, there should be a way for us to connect the two tables together. So we need the department ID to connect to the department ID. Imagine if you don't have the department ID, how can you connect the split table? We cannot connect the lecturer ID and department ID because they are having different values, okay, and it must identify correctly the records or the attributes in the table. So we need a department ID, okay, and this will act as a foreign key. Okay, so this will be a foreign key in our table. So what do? We can write here a broken underline to indicate that department ID is a foreign key. Okay, so don't forget, when you write on paper, department ID will become a foreign key. And then here, department ID is a primary key. So we put an underline. Okay, so again, we connect the lecturer and department ID via the department ID. So let's add a name. So this will be, again, like for the lecturer information. So we can see here the lecturer ID, lecturer name and salary, and the department of the teachers, we have department ID as a foreign key. Then, since this talks about dep ID, dep means department, so we write here table name as department. Okay, so let's make this big. Okay, so let's just copy the. Okay, let's see if we can get the line correctly. Oh no, so we'll just have to use this all borders, and then this. Okay, so we have here the department ID with underline. Okay, so what about the lecturer and course? So this is normalized already, so we just have to copy the lecturer and the course. Okay, so this will be now our tables in 3NF. Okay, so can you see now? From single table, through normalization, we're trying to remove the data redundancy or reduce the data redundancy and the anomalies of the table. So from one table, in 1NF we have 2, in 2NF we have 3, and in 3NF we have 4. So take note, the transitive dependency could be on the other side of the table. So just take a look at your columns and determine correctly where are the dependencies, the full, the partial, and the transitive. Again, it could be on the left side or on the right side. So just check on the table. Okay, so what will happen now in our table? So as you can see, we have the lecturer information, the department information, the lecturer, and the course code. So but take note, we have here duplicate value for the department. So we have to remove that part. Okay, so we don't want repeating values for our department. So there should be only D1 and D2. So we remove that one. Okay, so look at this class. When you normalize your table, we were able to remove the anomalies. So again, in our example earlier, what if there's a new teacher? So that will be lecturer ID 4. And then his name is Ahmed. Okay, he will be assigned in department IT, for example. So that will be D1. So there's no problem now in inserting new record for the lecturer. Why? It will not affect all the other tables like the department, lecturer, course, and the course ID. So we can simply add a new lecturer in our lecturer table. Same with the department. So if there's a new department, we can simply add it here. We can write D3, okay, for engineering, for example. So we can add it. So without affecting or waiting for other information to be added or details to be added in a table. So same with here, if we have a new course, we can simply add it here. So solving our problem with anomalies, the insert, update, delete anomalies. And also the redundancy. So from original table, we have here redundant values because we can see that lecture ID has been repeated. We have Shaima 2 times, Fatima 2 times. Also for the department, okay, so we have the duplicate values for that. This one is not a duplicate value because this is for the networking, okay, but here we have for the networking. So that's why we can reduce that by normalizing our table. So here we can just refer to the course code and connect it to the courses table. So we can still identify the course name based on the course code. So they are all still connected. So you can see here we have the lecturer ID, which can be still connected to the lecturer ID here. So if we want to know the courses that she teaches, so we can connect in the lecturer course, then connect to the course code using join. Remember, join or joining the tables. Also for the department, we can determine the department name by connecting the lecturer and the department together. And what else? Okay, so that's it. So all of them are still connected. So we can still join them using the join condition I taught you in the SQL. Okay, so now we have what we call the normalized table. So this should be your final answer in this example for normalization. Okay, so again, take note, label 1 and F, then remove the repeating group. Okay, copy the table, copy the lecturer ID here. So do not repeat the values in the lecturer. Here, there's no problem. Then in 2 and F, we have to remove the partial dependency. So using this table, we can remove it. So lecturer ID, course code here, and then teaching experience. And then we have the courses remaining, the partial dependency goes here. Then this doesn't have partial dependency, we'll just have to copy. But in 3 and F, we have to remove the transitive dependency. So we separate now the table for department and for the lecturer and make the department ID as a foreign key. So that's it for our normalization example. So for your practice, try the exercise number 2 here. So study our table. Where is the repeating group? Okay, what are your primary keys? So in this case, we have the order number and P code that determines the amount. So this is your full dependency. So try to do the 1 and F, 2 and F, and 3 and F. So that's it. Thank you.